Hi everyone, welcome to Moscan. So in today's video, we have been given one question in which CMOS inverter is used and the supply which is used for the CMOS inverter is given as VDD, which is having a ripple which is defined by A cos omega t. So this is a varying supply which is applied to the CMOS inverter. The input which is applied to the CMOS inverter is DC in nature and the output is having a capacitive load connected. We need to consider the channel length modulation, which parameter is defined by GD for both the PMOSs, PMOS and NMOS. And in this question, we have to calculate the transfer function of the CMOS inverter in J omega domain. So we have to calculate V out upon VDD for this question. If you see V out is this node and VDD is already given to us, so we need to calculate V out upon VDD in omega domain for this question. So let's start solving this question. So first of all, in order to calculate the transfer function, we will start calculating the current which is flowing from this PMOS and NMOS. So let's start to calculate the current flowing from NMOS and we will represent it by IN. So the IN is current which is flowing from MOS M2 here. Now if I have to write the IN current, I can write it as GM times VGS. So GM we know, let's consider the GM for this and MOS is GM into N, whereas the other parameter would be VGS of this NMOS. Since channel length modulation is also given to us, so we will consider that parameter also. So that factor will also get added on here. So GDN we will get, and that will get multiplied with VDS. So VDS means drain of this NMOS. Let's call this as VD minus source of this NMOS. This would be the IN current. Now we know the value of some parameters here. So if you see VGS source voltage is already 0, gate potential will be also 0 because it's a DC in nature which is given to us in question. So this will be AC ground while doing the AC analysis. So we will consider this 0. So VGS will become 0 for this NMOS. Now if we put these values in this equation, so what we will get, let's calculate that IN would be equal to, since VGS is 0, so this parameter will become 0 now, and GDN we will get along with VD is nothing but V out. This node is V out node. So GDN into V out, and source node is already sitting at 0. So ultimately we will get GDN into V out. This is the value of IN current which is flowing from NMOS. Now similar equation we will apply for PMOS. Let's call the current flowing from PMOS as IP and we will apply the same equation. So if I have to write IP here, I can write it as GM of PMOS into VGS of PMOS, plus we will consider the channel length modulation factor here also. So GDP into VD minus VS of PMOS. Right. Now if you see here, VS of PMOS is nothing but VDD, right? Which is given to us in this equation. And if I have to calculate VGS of PMOS, so I can write it as VG minus VS. VG, if you see 0, right? This is DC nature. So 0 minus VDD we will do. So VGS of PMOS we will get as negative times VDD, right? If I replace this value in this equation, so I will get IP equal to GMP into VGS value is minus VDD plus GDP into VD. VD is V out and VSP, VS is VDD, right? So if I simplify this, I can write it as IP equal to GDP into V out minus VDD, and since it will become negative after multiplication, so it will be GMP into VDD. So we have calculated IP and we have calculated IN. Now if we apply KCL at this output node, so I can write at KCL at V out. So if we apply KCL, we will get IP plus IN plus there will be some current going in load capacitance also, so we can represent it by j omega CL into V out, and this will become equal to 0, right? Now we know the value of each parameter we have calculated, so we can substitute. So if I replace this IP value here, so I can write this at GDP into V out minus GDP into VDD minus GMP into VDD. This is IP plus IN we need to do. IN we have calculated above, that is equal to GDN into V out, and plus J omega factor is for load capacitance. Now, if you see, there are two parameters. One kind of parameter is V out and the other one is VDD. So we can take a common here. So if I take V out as a common, I will get GDP plus GD of NMOS plus J omega into CL. Similarly, if I bring VDD parameter on the right hand side and I take common VDD, so I will get GDP plus GMP, right? Now if I have to calculate the transfer function H omega, that would be equal to V out upon VDD. So this will be equal to GDP plus GDN plus J omega CL divided by GDP plus GMP. So we had to calculate V out upon VDD, and that's what we have calculated here. So we had to calculate IP IN current, and then we had to apply the KCL at V out, and we ultimately reached on this expression where we had to calculate V out upon VDD. So that's all about this question. If you found this question useful, please share this with your friends, and if you haven't subscribed to our channel, please do subscribe.